Okay, so let's go ahead and start. And what we're doing today is we're going to write equations of cubic functions. This is typically the hardest part, but I did the lesson in my head about 30 seconds ago. And I think I figured a way to make this super easy for you. So I think that's my goal today is to make this as easy as possible. So basically we are going backwards. I'm giving you the graph and you're going to write the equation. So before doing so, in your notes, is the first one already filled out? It is, right? Like the table, sorry. Okay. This is the most important part of the equation. What I'm about to tell you is this right here. This is your parent function. This is your mother function. Okay? This is the one that we're going to base everything off of. This is going to be the most important point in the lesson, is going to be your home point. This right here is your home point, 0, 0. We're going to use that as a guide to help us write the equation. There's going to be a secondary point that we're going to use that's going to help us, and that's going to be the second point. So what I have up here is, this is your, like the DNA. This was, what is it, Adam and Eve? So Adam, was he first? Yes. It's been a while since I did Sunday school. So, so this is right here. I'll stick to math. So 0, 0, this is your home point. The next point that we're going to use is going to be the next one over. That they're always going to give you the next one over, which is going to be the 1, 1. So the DNA is 0, 0, 1, 1. That's what I'm going to use. I'm never going to use the third point. I don't need it. You only need the home, and you need the 1, 1 as a guide. All right. I don't think we need this over here, so I hope not. I'm going to cross this out.
So blurry.
Because, do you guys know Ms. Mosier? Yeah. I love Ms. Mosier. She was on the Algebra 2 team last year. She made these notes, so if you like these notes, you should thank her. She was a blessing to have on the Algebra 2 team. I do miss her. She was awesome for the math team, so, and math was not even her thing, but she was really good at it. She's just a good person at doing stuff. But anyway, she makes notes nice and pretty, unlike Mr. Lopez, plain Jane, boring as hell, and she just cleans it up. She just does a good job. Anyway, enough of bragging about Mrs. Mosier. Anyhow, so here, look at this graph right here. Okay, look on the left, and I think on your paper, I apologize, I think it doesn't look very good, right? So here is, always look for your home point. So y'all see that blue dotted line on my screen? The blue dotted line is the parent function. That is the main one, the 0, 0, 1, 1. Everybody with me? All right. So to determine the vertical stretch, you're going to use, you have to check that first. You have to check the home point and the secondary point. But before we do that, let's fill out the table to the right. If I look at the dark dotted graph, this one right here, the solid one, this one right here, which of those points is the home point for that graph? Zero, negative 4. Very excellent. This is the home point for the black graph. It moved. This up here, that's the home point for the dotted, but for the solid, this is the home point. Does everybody understand that so far? Okay. So go ahead and fill that in. So that would be 0, negative 4. We only need the next point up. So remember when I told you this is going to be the key. We need the home and we need the next point over, which is the 1, 1. On the solid graph on this one right here, which one represents the 1, 1 point? 1, negative 1. That one changed to that. So this one would be 1, negative 1. So go ahead and fill that out. We don't need the third point, but I'm going to go ahead and put it in. They gave us, we will always give you 3 points. You don't need it. The only ones we're going to focus on are going to be the first 2. Okay, so here we go.
You forgot the parentheses on the.
Oh, thank you, sir. All right. So here is what should we do first? Let's do the home point. The home point is always going to tell you the C and the D. What I mean by that is from yesterday. Do you guys remember this right here? The new home point is always going to give you this number and this number right here. Always. So I want you to look at your paper. Look at all you have to do is look at this point right here. Did the X change at all? No, there is no C. Does that make sense? See how this is your home point, the C did not change. Look at the home point here. What did that change to? -4. So that means that your D is -4. Your C and D, you always get them from your home point, the new home point. So that means that when I write the equation, you always put the cubed, here I wrote that too big. You always put the cubed right, that's a cubed right there, I don't know if you can see that. It went down 4, that's your D. It has no C. Technically it's X minus 0, but we're just gonna put X. Does everyone kind of follow what I just did? All you do is look at that home point. It tells you everything you need to know. Boom, we're almost done. Now I just need to determine if there is a vertical stretch or a compression. The way you can tell is you're going to look at the difference from here to here. You only need the difference from there to there. So I'm going back to the parent. What's the difference from here to here? 1. This has a positive. This is positive because it goes this way. If it was negative, it would have gone that way. So that's why this one, the equation for this one is x cubed with the 1 in the front. So what we're going to do here is we're going to determine what is the difference from here to here. This is a multiplier. It should have only gone up 1. How much did it go up? It went up 3. That is your vertical stretch. Your vertical stretch is 3. And I know it's positive because the graph stays, it has the same orientation that goes this way like that. We are done. This is now, your equation is going to be 3x cubed minus 4. G of x is that. It is the difference from these 2 points here. You look at the y's only. Sorry, I should have emphasized that. Look at the y's only. The difference between there and there is 3. The difference between those two will always give you the stretch. Okay? All right. So, let me have you guys turn the page. What I want you guys to do is, we were in this blank here, my bad, we were supposed to describe the transformations. But I think we did that in the warm-up. This goes, yeah, there's no space, but would we agree that this graph here goes down 4, vertical stretch of 3? Okay, we'll do this on the next one. So for number on A through D, or the very first example, can I have you guys fill this out? I'm gonna give you about 30 seconds. Just fill this out. I still wanna do this one together with you guys, okay? On this one, we don't have this point right here, the one that correlates with that one. So what I'm gonna do is, I just noticed that. I want this one in green. You see right here? That should be what, 3, 4? That's the one I want.
change to 3, 4?
Yeah, because I always want the home and the one next one over. Because, unless I'm wrong, let me see, hold on. No, I'm right. 3, 4. Wait, is it even? Yeah, it's going through the point. So I want this point here. And then the 2, 8, that would be 4, 11. And let me look at the, yes, I'm right. Okay. So, we need 3 things in this problem. I should have done this the first time. We need the A. For these questions, we're going to keep it simple. We're never going to find the B for when you're writing equations, because we can make this incredibly difficult. What we're going to do instead is we're just going to look for these 3 letters. You're always going to look for the A, C, and D. So let's do C and D. We have enough information to get your C and D. Can you guys tell me what is C?
No, I cannot tell you. It's a secret.
2. Yeah, good job. It's 2. It is positive 2. I want you to put a plus 2 on purpose. Then look at your, what is the D in this case? Positive 3. Remember that we get our C and D from your new home point. Now we just need to get our A, so we're going to get the difference. Look at your Y's. What is the difference from 3 to 4? Uno. So 1. So your A is 1. We are ready to write our equation. We're just going to plug it in. So we're going to do A. Again, we're not doing B, so I'm going to skip that part. So it'd be C cubed. And basically, you just plug it in there. So this would be 1. And I'll put the 1 so you can see that it's in the front. X minus 2. Notice how it's not positive 2 because insiders lie. It goes 2 to the right. It must be minus. Then this is going to be plus 3. If I was to describe the transformations, this goes 2 right, 3 up. That's all it does. And we are done. Very excellent. All right. These are, I'm not a fan of, you can use these. These do work. I would have given you the ones on the right, but we can still do it. So go ahead and see if you can do this problem start to finish. I want you to fill in the table. Find A, B, no, not B, C, and D. mister. Mhm. As you start finishing up, check your answers with somebody around you. You can always graph it too, right, to see if you got it right. This one's a little tricky with, there might be a negative somewhere. This one might, because this one flips.
So would be in the parentheses behind the x.
Yeah, but this equation, we're not using, we're not gonna, when you're writing equations, we're not gonna mess with B because it takes the difficulty of these problems to a different level. This is difficult enough that it suffice even for advanced. So I think we're just gonna we're only gonna look for vertical stretch and compression. We're not gonna do horizontal.
Yeah, but it does flip.
It does flip. So you must put a negative somewhere.
Yeah, and then the negative inside the parentheses. That's what it's right, and that's what B is.
Maybe look at your A value. What is the C value for this problem? -3. What is the D value? -5. So I know this graph goes 3 left, 5 down. What is the A value in this question? -1. The reason I know it's -1, it is difficult to see.
Bless you.
There's,
Thank you.
we really should be using the points on this side, so I could show you why. But the way I know is that this graph flipped. That's how I know it's negative. Because if I look at this, it should be going like this. If I make it negative, it goes the other way. Does that make sense? Okay. All right, good. So that's it. You're ready. So this would then be negative x plus 3 cubed minus 5. That is the correct way to write it. Check to see if you did it correct. When you put it in, when you put the C, always change the sign in the parentheses. It changes sign. You can always use Desmos to graph it, to check it, to see that you, yes, sir.
Are we allowed to put -1?
Oh yeah, if you put -1 here, 100%.
Okay.
It is absolutely 100% correct. If you did that, very good. Very, very, very good. Okay, so if I was to describe, this would be reflex over x-axis. It goes 3 right, and I am wrong, 3 left. And then it goes 5 down. And you can tell by looking at the home point, that's what it did. It went 3 left, 5 down, and it flipped. I'm gonna stop right here.
Wouldn't it be B instead of A because it's reflecting across the y-axis and not the x?
They look the same. If you flip this graph, if I do,
Oh, okay.
so technically on that's a very good observation though. If you did this on the test, if you put it as a B, and I don't know if Xander, but see, if you put it as a B, it makes it more complicated. Don't ever mess with the B, I'm telling you. I would just do, always make it your A.
Okay.
Trust me. It would look completely different. So, yeah, I'm not going to show you. But again, if I flip this one here, like if I do, I'll show you, I guess. So 3. So if I put the negative on the, let me put parentheses. If I put the negative on the outside, it looks like that. If I put it on the inside, it looks the same. They're on top of each other. So, yeah. Okay. So that's that. So your exit ticket for today is just to complete C and D. That's it. Just do C and D, and you are done for today. On that one, this is the one we did at the start of class. So it was 1 through 8.
Oh, okay. Just
Do you mean
don't
this
do
one? This one you have to do, that's what we did, that was a warm up at the start of class, so you don't worry about that. This one, for the grade, you have to do 1 through, basically 1 through 6. You don't have to graph them, but you do have to just put the points. What happened is as a vertical stretch of 3, reflects over the x-axis, and then choose any 3 on the back. When you are done with your 2 problems, you'll come show those to me just real quick. I just kind of look at them, put a check mark on it, just to make sure you're getting it. If you are in Miss Pam's class, go ahead and just, if you need help with the last 2, she has the answers. Go ahead and show it to her, just to make sure you did it right.
Ooh.